So here's the new feature I've been working on, which is getting the real image capture working on our confocal microscope. I'm using the actual Arabidopsis sample to capture the real images. The existing NIS captured the images from here. If you see, this is how it captures. But now what I have done is to fully automate this trigger. Instead of clicking it from the UI, we will trigger it through our script. I'm going to run this command, which is going to talk to the microscope, and as soon as I run this command, it will pops up the jobs UI for the NIS where this capture is happening automatically. This is where I have saved the files to save it in a separate folder, and all these are ND2 files, and we are saving all these details in a separate folder here with inside the capture, which contains the pixel size, the channels they have used to acquire. If you see, there is 5 FAM and TD channels respectively. Okay, so let me explain how I did this. So the very first thing is I am not using any SDK for that, because this capture thing is done inside the NIS and not the Nikon SDK. So if you see here, through my script I am calling a test capture jobs. This test capture job I have created inside the NIS itself and configured few things, if you can see it here. So the real challenge was how to trigger the microscope software to run a capture from outside with a script. So what I have found in the documentation is there is a command line option that lets an external process send a command into the microscope, and we can wait it to finish. So we are passing, our job name was test capture, and we are passing through the job, and we are using this command line option to call it simply. Let me show you the test capture configuration. So I have added 4 jobs inside this test capture jobs. One is the configuring the optical configuration. I have also added a storage location where I want to save it, and then I have written a Python script where to save the take the JSON data out of ND2 frames and save the pixels and everything in my local folder. This is what the configuration I have done to run the test capture job. So this is where I am saving all the ND2 captures data, the path which I have configured in the test capture job, and this is where I am acquiring all the pixel values and everything in my code repo, and all the capture with the timestamp JSON. The next feature I have implemented is moving the positions, which NIS provides something like that. Let me show you how it works. So right now the XY position is -7.1913 and something mm, but let's suppose I'll move this point to center of 8376, and if you see now, this is just changed, right? So this is happening through the NIS, but right now I have tried using my script, and will show you the same how it works. Let's do it through my script. So right now the XY position is -8 something and 9 something for the Y axis. I'm using this command where I'm moving the positions with X as 7908 and this. Let's run it. As soon as I ran it, if you see, the position before was 8375 and 7908, and if you see here in the UI also it changed. Let me show you one more movement where the XY position is 7908 and 9088, and now I'm moving it to 7918 and the Y to 9077. Let's move the XY both and let's see how it works. So if you see here now 7918, and you can see that in the UI as well it changed. So that's it. This is the script which is capturing the real images and doing the calibration of the images and actually moving the real microscope stage. And we have confirmed it against the real hardware. Thanks for watching.